All right, so let's really quickly kind of look at just the basics of the test components, even though I've already mentioned it. I just want to make sure you guys have it in a couple places. Then we'll look at biomes, and then we'll look at the phosphorus cycle. So you are going to be taking your test through AP Classroom. So make sure that you bring your school issued Chromebook. That's the easiest because it already has the Lockdown Browser app installed on it. You will have the full 80 minutes of class. It will begin right at 9:20. So go ahead and come on in, sit down, get started. It's 35 multiple choice questions, 2 free response questions that are very similar to the ones you saw on the primary productivity food webs quiz. Of course, they're not going to be 2 of the same ones, but the formatting will be relatively similar. And then you'll also have that carbon nitrogen diagram on paper. Do remember to bring a calculator, like a regular 4-function calculator from the Dollar Tree is fine. As long as it can add, subtract, multiply, and divide, you'll be good to go. The one thing is you cannot use the calculator on your phone, and you won't have access to the one on your computer. So you want to have one other than that. If you decide you want to do this on paper, every single problem can be calculated and answered without a calculator. I'll gladly give you some extra paper to kind of scribble on and do your math that way. Okay, and remember the math is, again, relatively simple. You're working with exponents, and you're basically doing unit conversions or being able to answer problems like that. Okay, so let's talk. So Jazzy has asked about biomes. So let's just kind of talk through the basics of those. So the 2 types of biomes that we have are terrestrial biomes and aquatic life zones. A life zone is basically the same thing. It's synonymous in terms of the biome, just because there's depth issues and there's other issues other than precipitation and temperature. We call them aquatic life zones. If you call it an aquatic biome, you're not going to get, marked down. You're not going to get marked wrong. Just know that if you see this written in a textbook or in an article that we look at or on the test itself, an aquatic life zone is the exact same as an aquatic biome. Okay. So how many terrestrial biomes are there? There are 7. How many aquatic life zones are there? There are 3. Within these different biomes, there are multiple different ecosystems. So you want to make sure that you are not confusing an ecosystem with a biome. Okay? Biomes are large, and span over multiple continents, large portions of the world. Okay? So for a terrestrial ecosystem, the 2 major driving components are temperature and precipitation. Okay? So are they hot, warm, cold? Are they wet, moist, dry? Okay? These things are going to be impacted by latitude and altitude. Okay, so remember, we're looking at, this is the northern hemisphere, this is the equator, this is the pole. So in latitude, we're looking this way. How far from the equator are we? Okay, in terms of altitude, do a mountain here. Altitude, we're looking at how far from the surface going up toward the atmosphere are we? Okay. High latitudes and high altitudes tend to have very similar characteristics, particularly if those altitudes are incredibly high. Okay, so when you think about those things, especially areas that resemble those tundras, you're thinking of like K2 in the Himalayas. You're thinking of like Kilimanjaro, right? So these are mountains that could be perfectly tropical at the base, or even a desert at the base. But by the time you get up to the summit of that particular mountain, it's very cold, very dry. So you have snow and ice on the top there. Okay. So basic characteristics of terrestrial biomes, right? Defined by temperature and precipitation, which are both impacted by latitude and altitude. Also remember that even across for both of these, that biomes are going to have similar organisms, similar flora, similar fauna. Okay, that'll be important to keep in mind when we start talking about adaptation and biodiversity in the next unit, because those similar ecosystems can lead to similar adaptive patterns. All right, so terrestrial biomes, let's kind of talk about them. So if we're looking furthest north, and I always prefer to do them north pole down to the equator. So the highest one is going to be the tundra. Okay. And remember that this one has low temperature, low precipitation. Okay. So it's going to be very cold, very dry, with permafrost. Okay. This permafrost is going to help protect and insulate a very thin layer of vegetation underneath. That vegetation basically lives its entire life cycle underneath that ice. So it's born, it germinates, it grows, it dies, it decomposes, and as it dies and decomposes, it produces carbon dioxide, and more importantly, it produces methane. And as the overall average temperature of the Earth is rising, that's leading to melting of the polar ice caps. It's melting these tundras, melting the permafrost, and that's releasing large amounts of methane into the atmosphere that prior were kind of protected. So it's helping to increase that problem of global climate change. So there's your tundras, all right? So we're going to move further down, and on the edge of a tundra, or at a very high altitude, we have a taiga, or a boreal forest. Okay, so these typically have kind of moderate temperatures, moderate rainfall, and relatively low precipitation. Okay. These areas are going to be the ones that you find that are evergreen. Okay. So these are those trees that have needle leaves. They don't really drop their leaves the way like oak and maple do. A little bit more organisms is where you think like reindeer tend to live, right? You would also find these at high altitudes, not as far up as you would find the tundra on things like K2 or Kilimanjaro, but these will be found in very similar places. Okay. As we go from north down to the equator, we're going to go through that taiga, and we're eventually going to end up hitting the temperate forests. Okay. So the temperate forest is kind of middle of the road in both places. Okay. It has very distinct seasons, which is one of the defining characteristics of a temperate forest. Okay, very distinct seasons. You have a warm season, you have a wet season, you have a dry season, you have a cold season. And with the temperate forests, examples of those, you could have a temperate coniferous forest or a temperate evergreen forest. You could have temperate deciduous forest. Sorry, my whole thing just kind of went sideways on me. Okay, so the temperate forests are really going to be defined by what kind of plant life you have. What are the trees like? We are in a temperate deciduous forest. So yes, there may be conifers that exist in this ecosystem. But if we look at the overall patterns, we look at the overall organisms across average on this particular biome, they're more likely going to be deciduous trees. Therefore, we are a temperate deciduous forest. Okay. As we continue on, we may come in contact with a grassland or a savanna. And remember that the difference between the two is that grasslands cannot support trees, savannas can. Okay. These are typically going to have relatively warm-ish temperatures and moderate to low rainfall. Okay. And that's going to entirely depend on its location compared to water sources. So savannas or grasslands that are near large lakes, large bodies of water, may get more precipitation than those that are far away from those things. So in the US, grasslands are like those Midwest states, those prairie states. And that's the majority of the land in the US is this here. Okay. As we move from grasslands or savannas, we are going to travel through the chaparral. Okay. Remember, we also call that the shrub forest, the Mediterranean shrub forest. And this one is going to have slightly higher temperatures and slightly lower precipitation. This is because chaparral are transitional ecosystems between grasslands, other ecosystems, and deserts. Okay. And we know that deserts have very high temperatures, very low rainfall. Okay. This is also going to let us know that we have distinct and extreme temperatures. Okay. So it's very, very warm it's very, very hot during the day, very, very cold at night. Okay. And lastly, we have our tropical rainforests. You can have a tropical deciduous forest for the purposes of apes and the purposes of your exam just across the board. It is just a tropical rainforest. Okay. And we know that tropical rainforests have high temperatures and high precipitation. Okay. Because of that, they're going to have some of the highest net primary productivity. Okay. So let me make sure that I let you know, give you a little key here. This means high, this means low, this means moderate. Okay. All right. So those are our terrestrial biomes, right? And remember, you may see them on a climatogram. Okay. Climatograms are a biaxial graph, meaning they have two y-axes that may have independent scales or measurements. And then, of course, you're going to have a single x. In this case of a climatogram, the x is going to be time, usually in months. So you'll have January, February, so forth and so on. One of the axes will be in temperature. Most often it's in Celsius, but you may also see it in Fahrenheit as well. And then the other would be in inches or some other measure of rainfall. You may see it in meters, you may see it in centimeters. Inches is one that we're commonly seeing. So to read this one, what you would do is look first at the line for precipitation, for example. So we would look, this is the one that we would be reading. If we want to see, how wet is it in January? So we would look at where the point is there, right? So they typically have two lines, okay? So one of them will be about precipitation, another one will be about temperature. And they will very clearly say, this is rainfall and this is average temperature over time, okay? You'll be very clear as to which one is which, all right? So there's our terrestrial biomes, okay? Basic things that you should be able to do or be able to figure out given information. Very much like some of the Kahoot questions that you had, some of the questions on the practice test, post-test. Those are kind of exemplary of some of the things you'll be asked to do. All right, questions about terrestrial biomes. And for anybody who just hopped in, don't panic. This is all being recorded and I'll post it up on Canvas tonight so that you guys can rewatch it or catch up anything that you missed. All right. So let's talk about our aquatic life zones. Okay. So where terrestrial biomes are identified by temperature and precipitation, aquatic life zones are defined by salinity, which is the primary thing. We're looking at salinity first, and then we may start looking at depth or photosynthetic ability. Okay, but salinity is the number one defining characteristic that we look at for aquatic life zones. So the majority of the surface of the planet is part of the marine life zone. Okay, so marine life zones are very high in salt content. Okay, and here you can see examples of obviously the open ocean with all of its components. So you have the intertidal zones, the benthic zones, bathyl zones, that kind of thing. All right. You have corals and coral reef. You can have saltwater marshes. Mango swamps, things like that. Mangrove swamps. But the defining characteristic is high salinity. Okay, and approximately 73% of the planet is made up of marine life zones. Okay, the next one is going to be your freshwater life zones. Okay, so freshwater life zones have a low salinity. Okay, probably around 20-ish% of the water on the planet, or the aquatic life zones are made up of fresh water. Yeah, made up of fresh water. So within this, you would have lakes with their littoral zones, so those edges on the shore, the limnetic zones, which is the majority of the water itself. You have rivers, you have streams, You may have some freshwater marshes, freshwater swamps. So you'll have those there. The last one are our brackish biomes. Okay, brackish biomes, and I know I misspelled brackish, are your estuaries. Okay, those places where freshwater, saltwater meet. Okay, so brackish salinity is somewhere in between. Okay, so these are, your estuaries, your deltas, some of your marshes. The marsh is really dependent upon the salinity. Okay, usually the best example of a brackish biome is an estuary. We tend to use that one a lot. Okay, and roughly about the remaining 7% of aquatic life zones are brackish. You don't have to remember these numbers. It's just kind of let you see volume wise where these are, how much they show up, how much of the planet they take up. Okay.
Miss King.
What, Ishan?
What specifically will we need to know for the test? Like all of it? Will we need to know all of this?
What do you mean all of this?
Like we have to memorize like all of this, like that is on the screen.
It would be good for you to be familiar at least with this information.
That is all I needed to hear.
When I say that, I mean, can you tell me what defines a terrestrial biome? Can you give me the basic characteristics of any of these terrestrial biomes? Could you, in theory, read a climatogram? If you could do those things, you have the information you need on this slide or this screen.
Okay.
And you can always go back and rewatch anything that you missed if you came in after I started, because it's been recorded. Okay. One last thing to remember with your aquatic life zones. Remember, one of the defining characteristics is going to be your depth or your photosynthetic activity. That's really going to help you determine specific ecosystems within these locations, like the oceans, right? So in an aquatic ecosystem, you have basically two layers in there, right? So you have one layer that allows light to penetrate through, okay? This is called your photic zone or the euphotic zone. Then you have another portion where the light cannot penetrate through, or the light is very, very dim. This is called the aphotic zone. Okay, so we're not going to expect photosynthetic activity to happen here, but we may expect it to happen here. Okay, so that's just another thing to think about when we're thinking about depth and photosynthetic ability in these places. All right. So if you have any questions, please feel free to throw them in the chat box. The other thing that I was asked to discuss was the phosphorus cycle. So unlike the carbon and the nitrogen and the hydrologic cycle, you are not expected to be able to draw the phosphorus cycle or label the phosphorus cycle. I'm going to show you exactly what you need to know for our purposes. Okay. So the one thing that we know about the phosphorus cycle that you should be able to answer all the time, no matter what I ask you, does the phosphorus cycle have a gaseous component?
No.
No, it does not. When the phosphorus is in the atmosphere, it is in the atmosphere only as what?
Aerosol.
Very good, as an aerosol. So as some kind of water droplet with phosphorus in it, okay? It is not a gas. So no gas. Okay? 9 times out of 10, when you're asked about the phosphorus cycle and how it's different, it does not have an atmospheric component, because for the sake of apes, and don't ask me why they do this, they just do, atmospheric component and gas are synonymous for them. Okay. So if you see something that says which of the following does not have an atmospheric component, and it's carbon, nitrogen, phosphorus, and sulfur, phosphorus is always going to be that answer. Okay. And we'll talk about the sulfur cycle when we talk about pollution in a later unit. Okay. So phosphorus is naturally found in its largest reservoir, which is the lithosphere. Okay. Remember, we're learning our Latin and our Greek. So sphere means, in this case, circle. Litho meaning rock. So this is the circle of rock, or this is the portion of the earth where you're going to find rock is the major piece. So soil, literal rocks, that sediments in the deep sea, those kind of things. Okay. So it's naturally in the lithosphere. The natural way to get it out, so the natural release of phosphorus from the lithosphere is through uplift and weathering. Okay. So geologic processes happen, the rock gets exposed to air and water do the weathering process, and that phosphorus is now released into the soil, potentially into water sources where it can be used. Okay, this is a slow process. So even if the phosphorus does get into the water, it's at such a small amount that it's helping the algae, for example, grow at a normal rate. Okay, natural phosphorus released from uplift and weathering, just about the perfect amount to allow appropriate photosynthetic activity in bodies of water. Okay, this is normal. All right, humans get involved and we mine it. Okay, and we mine it at extreme rates. Specifically because we love to use phosphorus for soaps, detergents, because it helps with foaming and bubbling in hard water. We're going to use it for some pesticides. Okay, I just want you to hold that thought, know that that exists, but we're going to come back to it in a later unit. The big thing to know about phosphorus use is fertilizer. Okay, and that fertilizer is going to be in that form of NPKs, right? Nitrogen, phosphorus, and potassium. Okay, so we mine phosphorus, which accelerates this process very quickly. So it makes this a fast process. And of these, the vast amount of phosphorus that we get in inorganic phosphorus ends up in fertilizer. Okay, so we put fertilizer on our fields, and we usually put a lot of fertilizer. It's not, do we need some? It's, we're going to use some whether we need it or not. This fertilizer, some of it gets absorbed into the soil, some of it ends up assimilating in plants, but a large portion of it doesn't. Okay, so we get a rainstorm, it rains, this fertilizer is going to go through runoff, and it's going to follow the rule of gravity, and it's going to follow the course of least resistance, and it's going to end up in some body of water. Okay, and should the conditions be right, that body of water is going to have some algae in it, and this is going to lead to an algae bloom. And I say that this is an algae bloom on steroids. Okay, because algae blooming is a normal process, right? Naturally, this is the process of eutrophication. So the algae grow and multiply, and then they run out of resources and they die. And then they grow and multiply and they run out of resources and they die. And the cycle is relatively balanced so that there's no major damage to the ecosystem. There's nothing that prevents other organisms from surviving there. But when humans get involved, this algae bloom, as I said, gets on steroids, and we get what's called cultural eutrophication. Okay? And we call it cultural eutrophication because it is human caused. Okay? You may also see it called anthropogenic eutrophication. Okay? Latin, Greek, the suffix IC means process of, Genesis means beginning, anthropos means human. It's the process of beginning with humans. Okay? So we cause this overgrowth of algae. Okay? So the algae over reproduces. It begins using up all of its resources, all of the oxygen, at a rapid pace. Right? So we're going to end up dropping our dissolved oxygen content, which is what DO2 stands for. And if there's no dissolved oxygen, other organisms can't survive and can't live. And you're going to end up with these massive fish kills in these anoxic or dead zones. Anoxic just means without oxygen. Yeah. Okay. And this, if it goes on long enough and you have a good enough, what we would call mat of algae, if it gets thick enough, you can eventually reduce photosynthetic activity because nothing gets through. Okay. So in order to really discuss the phosphorus cycle, the things that are important are to know what is the major reservoir or the major sink, lithosphere. Naturally, slow process comes from upwelling and weather. Human caused, fast process, used for the vast majority in fertilizer, NPKs. Excess fertilizer goes through runoff into bodies of water, leads to cultural eutrophication, where algae blooms grow out of control. They suck all of the oxygen and nutrients out of the water, and you end up causing these dead zones, which also lead to fish kills. And under the right circumstances, you can decrease photosynthetic activity at that particular place. And phosphorus does not have a gas component. If it's ever in the atmosphere, it is as an aerosol, not as a gas. Okay. Take a second and look at those, see if you have any questions. Those are the only two things at this point that I was asked to go over. So if there's anything that you think of that you would like for me to look at, please feel free to drop it in the chat, come off mute, say it, and I will gladly go over it or talk through it or whatever we need, because you still got me for about 20 minutes. Briefly on thermodynamics, absolutely. Oh, I forgot something with the phosphorus cycle. So why does the phosphorus cycle, why does phosphorus and the same way nitrogen, why do they lead to these algae blooms?
Because phosphorus is essential for plant life.
Phosphorus and nitrogen are both essential for plant life, essential for, God, I forgot how to
Plant
spell.
growth.
Not just plant growth. They are important for every living organism to have. Okay? They are what we call limiting factors. If an organism doesn't have them, their ability to do their bodily functions, do their cellular functions, is going to be drastically reduced. Okay? So every living thing uses phosphorus and it uses nitrogen. What are the two major things that a living organism uses phosphorus for?
Oh, ATP.
Yep, we can use it for ATP. Right, so we're going to use it as that energy transfer molecule in the cell, right? ATP is an adenosine nucleotide with 3 phosphates attached, adenosine triphosphate. Okay, what's the other thing we're going to use it for? This might be an A. This might be a T.
DNA.
Could be used for DNA. Okay, because remember, this piece right here of ATP is basically a nucleotide. Okay, same basic structure, just got 2 extra phosphates attached. Okay, so organisms are going to use phosphorus for ATP for DNA. You have to have DNA to be able to regulate all the processes in the body or in the cell. You have to have ATP to be able to run all those processes. All right, nitrogen, same thing, limiting factor. 2 major things that it's used for within any living organism. What are they?
Amino acids,
What is an amino acid part of?
DNA and RNA.
Now you got 2 different things there. DNA and RNA, yes.
Okay. Proteins. Yeah.
There you go. Amino acids are the building blocks of proteins. Okay. So for either one of these, so for this one or this one, if you said nucleic acids, pretty much any reader would give you credit for that. If you said RNA, pretty much any reader would give you credit for that because you are correct. They are used for those particular things. All right, so those are those things that I forgot for a minute on the other. So let's talk thermodynamics. Ooh, didn't mean to add an extra page there. Nope, yeah, I did. All right, so let us practice thermodynamics. What does it mean?
Something with heat or heat energy. Or,
Okay, thermo means heat. Remember, the suffix ic means process of. Dynamic means, or dynamos means movement. So the process of moving heat. Okay, or in this case, we would say the process of moving energy. Okay. So thermodynamics is just looking at how energy is moved through different kinds of systems. Okay. And we are looking particularly at ecosystems and food chains and food webs and trophic levels. So there are 2 major concepts within thermodynamics that you should know. They weren't necessarily named this way when you learned about them. Same concepts, you just didn't have this particular name for them. So the first law of thermodynamics says that energy can't be created or destroyed. So energy always is. but it can change forms. Okay, so what this means is we can take chemical energy and turn it into kinetic energy, turn it into electrical energy, and then turn that into potential energy of something stored. Okay, and I know I just, screwed that up when I was doing that. So the energy is still there. We haven't created any new energy. We haven't lost any energy. We're just changing it from one form to another to another. This law is also termed the law of conservation of energy. So Anish, I see in the chat box that you've mentioned that it's the law of conservation of energy. We conserve it. The second law is about conversion. Okay, so the second law says that no energy conversion is 100% efficient. Okay, so every time we do this transfer from chemical energy to kinetic energy to electrical energy to potential energy, some of that energy is lost. And when I say lost, I mean converted into a form that is unusable. So if you hear me say lost energy, what I mean is unusable energy. And by unusable energy, what I mean is heat. Because that's where most of this lost energy ends up as. Okay. You may also see this mentioned or talked about as low quality energy. Same thing. Synonymous terms. Okay. This law is where we get that rule of thumb that you work with when it comes to ecosystems. This is where you get the 10% rule. All right. In an ecosystem, in the transfer of energy through a trophic pyramid, the amount of energy transferred from one level up to the next is approximately 10%. Okay. So on the first level of a trophic pyramid, where you have your primary producers, your photosynthetic organisms are, trying to find the right way to word this, are theoretically able to access 100% of the solar energy that reaches them. Okay. When that primary producer is consumed by the next step up, which would be a primary consumer, and remember, these are exclusively herbivores. Okay. Only 10% of that energy is going to be transferred. Okay. Because this producer has been using that energy to run cellular respiration, to make biomass, to go through the process of producing reproductive materials. So not all of that 100% of energy actually ended up in a way that it can be transferred up. Okay. So this primary consumer is going to be consumed by a secondary consumer, which can be either an omnivore or a carnivore. If it's an omnivore, there is potential that it could be eating directly from the producers, which would give it that 10% shift. Or if it's a carnivore, it's eating the herbivore and only getting 1% of that original energy. That consumer gets eaten by the tertiary consumer, which is most likely a carnivore. That's going to end up getting only 0.1% of the original energy. Okay. Let's say that this consumer ate the secondary consumer here, which is actually an omnivore, so it can eat grass at the same time. It's going to get 1% of that original energy. Okay. The energy transfer is based on what is being eaten. Okay, so if an omnivore is eating herbivore, it's only getting 1% of the original energy. If it's an omnivore eating the primary producer, it's getting 10% of that. Okay. This also helps us to explain why most trophic pyramids have no more than 3 to 4 levels. Because the amount of energy that ends up in this upper area of the trophic pyramid, or these apex predators, because there's so little energy that gets transferred, they have to eat more food in order to meet their body's needs for energy. Therefore, there are fewer of them, and they tend to be smaller in size. You think lions and wolves are huge. Yes, they are. But bears and buffalo and bison and reindeer and all of those other things are really big because they eat further down on the trophic pyramid and get more energy. Okay, so you may find a lion that is huge, but you're probably only going to find 1 or 2 in a particular hunting ground, and that's why it's not enough food to go around. All right, you got me for about 8 more minutes. Any other concepts you would like to address? While I'm thinking about it, every single biogeochemical cycle obeys what law?
Law of conservation
law.
of mass.
Law of
First law.
conservation, not of mass, but of
Energy.
matter. Biogeochemical cycles are actually converting matter, right? We have nitrogen moving. We have carbon moving. It's conserving the matter in those elements. So Ishan has asked, what do I think is the hardest thing on the test? Honestly, I think that's a little bit of a trick question because I think these first 2 units are the easiest units in the entire class. But of these, typically the biogeochemical cycles give people a lot of trouble if they haven't prepared for them appropriately. And the math on these trophic pyramids, if you don't pay attention, gets a little fuzzy. But if you take your time and you read your questions and you answer the question you're being asked, you don't try to overthink it, you don't try to add more to the question than there actually is, it shouldn't be that bad. I mean, a good number of you scored really highly on the pretest. So you had a good ability to identify some background knowledge of these concepts at the beginning. And you've had time to go through these. Some of you have gone through them multiple times. You're here, you have practice tests, you have the study guide. I think you guys have everything that you need to be successful the first run through on the test. The one thing that I would say, just in terms of procedure being difficult, is the FRQs. Most of you did a great job with responding to those FRQs. But general things are, unless you're asked to identify something, complete sentences. We've already said if it's the math, you got to show your work in an FRQ, and you got to use the factor label method. But for example, let's say you're asked to identify one solution to this problem, and you give me 2 solutions, and the first one is wrong. Only the first one is the one that gets read and scored. So if your first one is wrong and your second one is beautiful and perfect and absolutely right, the second one never gets seen. We reread the first one, score it, and move on. So make sure that you are answering only the question you're being asked, giving only the number of responses that you are asked to give, and that you're clear. So if you use a term, define the term. Okay. And you guys are getting my FRQ spiel, so because I usually do it after the first test. So you've heard that there. And Taylor's asking about the format of the test. So that's one of the first things that I kind of had up as people were coming in. So it is 35 multiple choice questions with 4 answer choices, A, B, C, D. 2 free response questions that are very similar to the ones that you've already done in terms of length and complexity. And then I'm going to give you the paper copy of the carbon and nitrogen diagrams to label. You'll need a calculator that is not on your phone or on your Chromebook, so that you can do any math problems that pop up. And in terms of math, remember you're doing potential unit conversions, working with exponents. It will start right at 9:20, and you will have the entire 80 minutes of class to work on it. You want to make sure that you are there on time. The only excuse to get extra time is if your bus was late. Yes, these FRQs come from AP Classroom because your test is on AP Classroom. So you'll be given like a little, okay, here's the problem that you're looking at, or here's the topic that you're looking at. Okay, here's question A. Here's question B, but there's now 3 parts to it. Answer question 1, answer question 2, answer question 3. So do make sure, I'm glad that you reminded me of that, Ishan. So let's say it's got 3 parts, right? So what you should do is identify B1 or BI, because they use Roman numerals. Answer that question. B2, answer that question. Don't write it in one long paragraph because it's hard to find all of the pieces, and you don't want a grumpy reader, because grumpy readers tend to be more strict readers, no matter how they try to avoid that. No fluff, just answer the question. You don't have to recopy the question. You don't have to restate the question in your answer. Just get to it. Any other questions, thoughts, concerns? Again, this is recorded, so you'll have a chance to go back and watch it if you'd like. And you can see the animations in real time. All right, well, if there are no additional questions, I will hang around for a few more minutes in case you think of something. I will have another session tomorrow. I think it's at 4:30. Kind of the same process, right? You show up, ask questions, say, I want to worry about this, I want to talk about this, and we'll do that. I'll record it, throw it up. You can rewatch it. So at this point, I'm going to stop the recording.